All right, good afternoon, class. Let's go on to our to share screen. All right. Okay. So today class would be on this still introduction. I am still trying to not to say not to frighten students with statistics. So last week we have learned a lot of terminology. If you remember your terminology, or shall I call upon names to answer my questions? Anybody want to recap back what you have learned last week? Nobody want to turn on even your. All right, so the recap for last week is a lot of terminology and how do you define the starting point of statistic. So the starting point is that you have to determine your subject and then your variables, what kinds of variables belongs to, and then the kind of variables that you have selected can be from different level of measurements. And we will go into this today and show you a little bit background on graph and figures and how to keep you motivated. Because I have asked a lot of students or my colleagues, like, what is the main thing that keep you keep you having fun or makes you trying to be involved with this statistic? Because every time comes with statistic, a lot of like, I don't understand how does the test work. So, and then last week, I also showed you some softwares, and the softwares that I mentioned to you are generally those software that are free. Okay, there are a lot of softwares available outside, but most of it need to buy or need an account with some charges. So like R is the most common right now because R is free. As long as you write in the commands, they will give you whatever information that you need. And then Excel comes to it very easy because Excel prep everything that you can put in your data, and then they can generate figures, and then they can generate statistics for you. And it can be extended, and then you can extend the Microsoft Excel into more details of data analysis. But most of the time is that there are always limitation of certain packages of software. But R is a software that most of the scientists use right now. I also use, but then R is that you have to write commands. And for our education, command is not common. But starting, I think your younger brothers or sister, you will see them. There are a lot of courses that need commands. For example, engineering, a lot of other stuff. Somebody text me on Elon. Tak boleh masuk link. Mira ni masuk kelas mana ni? Alright, so a lot of the time is that the software, we don't teach you the software directly, but along the way we will show you some. And to stay motivated is actually how do you create the graph, because graph is the items that you need to present it out, and people would ask you what is the components, because in statistics you learn that we have to collect data, we have to go to field and collect data, we have to come and analyze data, clean data, okay, analyze and present the data, CO, collect, organize. All right, So for organization and collection, if you know that if you're going for kerja lapangan, if you were at kerja lapangan last year, it was more appropriately saying that you would have a slate board and then you can write down what are the information that you have collected. But in a larger scope of science, it is no longer just writing down that one A4 or one half A4 size of piece of paper. For example, data for water quality or water temperature, it comes up to have hundreds and thousands of data. And those kind of data is not just write it down. You cannot write it down because you have a lot. For example, you have 300 species of plankton, 300 species of items or water bottles, water collected from Pulau Bidong. There's no way you want to write and single information into a book. You have to write it in an Excel where you can categorize them into different category. That's why your data sheet is very important. You have to know what is your individual's object. For example, water quality. So you have station 1 until station 50. And then what are the items? They are not variables yet, but what are the items need to be collected? Like date of sampling, time of sampling, the weather of the sampling, who collected the sample. That is all data collection. Then after that, we go into variables. Variables where you collect the data according to your individuals, and then you put it into a big, large data set, right? So after you have the large data set, you need to present it out. That is the problem when presenting graph or figure. So today is just like introduction of what kind of figures that are suitable and what are the usage of each figures and graph. So let's go to the next slide on this. So case study number 1. Example of this is that from this graph, what information can you collect? What information that you first visually see? What are the items?
Years,
First,
Gender.
yes,
male, female.
male and female. So you can see in one diagram like this, the first thing you will see the X label, the Y label, and the legend. You don't concentrate on the level, you don't concentrate on what is the number, okay? You don't concentrate on what are the numbers, but you would directly refer yourself to what are the X information that you are giving us, the years, and then real wages, wage or salary, wage is the English word in US where they use wage, and then after that, compare between male and female. Once you have that information, then the next thing you want to see is that now we know male have more wage than the female because the line is upper than lower. So this is a direct information that you presented to your audience. Your audience can be reading a journal. If reading a journal, normally your audience would be academics. So there would be there would be a lot of questions when you present this to me. Like, how do I know? How do I know how many people that they questions? Or how do I know if the data is significant or not? So the questions of statistic here is that most of the time, people would ask, is the data, what does it reflect? What information can you gather? And does the information is statistically proven? Means, for example here, the male have higher wages than the female. Is it significant or not significant? Significant means the statement is proven to be correct. Not significant means it is not proven or it is not true. So is my statement significant or not?
Significant.
Significant.
I think.
Okay. So when it comes to significant value, what are the value? You cannot say, oh significant, macam like saya menyokong, okay, tak boleh lah agak political sangat. Saya cannot political, then I cannot think of anything. Like, okay, now like male and female, okay, both are trying to have equality, male and female. So of course, from this graph, we know that male are distinct, more wages than the female. So it's a data set that can represent. But for science, for scientists like us, that answer is not proven because we have not done the test. So we need to do tests. So that test would tell us the P value, the R value, the F value. This one we would learn in the next few weeks. What are the values that statistics are looking for? All right. So we are not going into that yet, just to make sure that you know that the main thing of your data, you collect the data, you present, and the data that you present must be well presented and must be proven with some statistical tools, right? Okay, next slide I'm show you. Show me what you can see from here. Tell me what you can see from here, and tell me what you can see from here.
Value of salaries.
Okay,
Salary.
value of salaries, minimum of salaries for the year of 2018, because that is in the title, right? That's in the title, the salaries, minimum salaries for 2018. Okay, we doesn't know what is MLB, NBA, NHL, and NRF. I think this is the, because I got this from internet. I think this is the basketball team player, the MPL player, the NBA player, the NFL. No. NBA is basketball. NFL is football. NHL is don't know what ball, and then MLB also don't know what ball. All right, so like this is the category of minimum wage if you go into this. But what else? What are the problems when you see this graph? Try to be critics of information. What kind of information that you would try to add in from here for this graph?
Average. Oh,
Comparison between sports. Okay, when comparison between sports is for this, it should be even in a graph, even in text, there are legend, there should be mentioned, there would be legend. Legend means label of your x-axis or your y-axis. Okay, that one somebody put in on the chat room just now. Okay, legend. Okay, the color. Okay, Fetch say got color. What are the differences of color? All is blue and one is yellow, and the yellow is the lowest. So the studies, because we don't know what is the studies, right? So the studies might imply or want to highlight to you that the NFL players is the player that has the most minimum salary. So want to highlight, right? But other criticals that I want to mention is, okay, dollar. Fine, it's dollar. But do we need to put all the 0000?
tak perlu.
Tak perlu. So we can actually put here the label of the y-axis to be salary, and then in a bracket of dollar times times 100,000. 100,000. Sialah, 100,100. So that, okay, I go to chat room. So that it will be written as salary. Okay, it would be written as minimum salary would be dollar. Where's my dollar sign? Dollar sign of 10 times 1, 2, 3, 4, 5, 6. Power of, not times is power. So the power is, what's the symbol of power? This one. All right, so if you write that, so you make this smaller, and you can have just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for science. But for management, they will of course want to see all this number value. All right, and then there is no minus. I don't think this is S minus. I think this is the 0. Okay, what other factors that they want to present the data to be like this? What kind of figure is this? What chart is this?
Bar chart.
Bar chart.
Bar chart, all right? But this bar chart comes into a square. You can see then it's not the normal bar chart that is 2D. This bar chart is 3D, right? So when it comes to 3D, for science, what is the function of 3D? It should be presented as in 2D because we just have X value and Y value. We doesn't have the Z value. 3D means we need to get the X, the Y, and the Z, means the extent here. All right, so you can clearly see that now the data, this one is for people to present to lay person, means to look the graph nicer, but not for science. Science would critics, we would critics on each of the definition. Why do they need to have bar chart? Why do they need to specify this? And why do they have the Y legend? So it's different concept. Depends on what, how, and where you want to present your data. But most of the time for students, for example, we ask you to write a report of the height of students. And then you have that graph. And the same graph you put into the report, the same graph you put into your presentation. Right, that is one kind. And then next kind of graph would be like this. Okay, so now what do you see? What are the problems of this figure?
Started with 3.
It started with 3.
So is it supposed to start with 0 or what?
Uh,
The Y axis.
yeah. If
The
it start
lecture.
with okay, too many 0. Okay, so let's go for Y axis. So for Y axis, do we really need to start from 0? The question is from some of you. Okay. So it's better if it's a bar chart. If it's a bar chart, you should start with 0. Because 0 to 3 is just a small number. It's just that because it's 3, 6, 9, the value is, it's just that when it's 0, you have just another bar. So there is no differences if you have your 0 or non-zero. So it's better that we put in the 0. Over here, you will see that the title is number of employees per salary. So the Y-axis should be the number of employee. Okay, numbers of employees. Even though there is a title, in science, you should have your Y label. You cannot miss the label of Y and X. It must have labels. So these both have non-label. Of course, no label. Somebody mentioned, Hema mentioned, all right. And then Alia mentioned too many 0. Okay, now it comes up to the x-axis. There are too many 0, same like just now. We need to have a standard. Okay. And then Nor Afifa also mentioned neon bar chart, not fully bar. Okay, this is a good point because why are the function of neon? What are the function of neon? Unless you are in disco, unless you are in pub, then you need your neon light lighten up. But if you want to present it into a management, you should have a bar with full color. Like emphasize what are the color of each bar and the number. All right. And then less than this is less than 30,000, this is more than 100,000. So the range of it is they can also use by category. Category 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. If it's categorized as 9, because I will see the standard is every 10,000. 3 to 4, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100, and more than 100. Right? So you can have a category and then saying that category 1 is 30,000 to 40,000. So you reduce the number or the label, and then you can say in your x-axis there is labeling of saying category characterized by the range of salary. Okay, so these two figure that I showed to you, this figure and also this figure, this is all figures for management, for layperson, for newsletter, or for, I mean, a general information. But when it comes to statistics, I will show you the statistics kind of figure. When talk about education and about wages, they are no longer just by on figure. The first figure I showed you was on years, right? The years, the first one, this one. This one on years, right? And then after that, they were on category of different sports. And then different category of salary per employee, right? But when we come to science, it's no longer just the bar chart. There is no longer the line chart. But what kind of information that we need to collect and put into the figure. So if you look here, an overview of statistical learning is that what are the factors to determine. So goes back to last week where we learned about what are the variables. Okay, so when we want to determine and scientific questions, we want to know what are the influence of wages, what are the factors that determine the wage of a person. So in these books by James et al. In 2013, it mentioned that there are 3 factors: age, the year, and education level. So for example, this education level, it categorized in 1, 2, 3, 4, 5. So the character of each education level, it would be written in the text. For example, category 1 as primary school, secondary school, tertiary diploma, or higher educations, for example. And you look at the data that have been collected, it's not only present the mean value, minimum value, maximum value, or average value. It presents all the value that you have collected. So you can see this is your median value. Okay, you have to, I think you have to go back to mathematics class a bit. What is median? Okay, what is mean? What is variance? Okay, all this terminology comes in, and then you have to determine your maximum and then your minimum. All right. So for example, this third figure where we have wages and then the education level, then this is the normal range. Okay, and all these dotted at the up here is all the outliers. Means in every group or any statistical analysis or any data that you have collected, there would be outlier. If there is no outlier, means your data or your population is being clustered or being analyzed. One example, like CGPA level of students in UMT. Okay, so if I only ask marine science and marine biology student for the statistic analysis, it doesn't represent the whole UMT. If I only ask, for example, 10 of marine biology, 10 of marine science, and then maybe all the marine science very high CGPA and all the marine biology very low CGPA down here. But averagely, we cannot mention that they are average. There are people that have higher, for example, education too. There will also people with higher wage. So these explain by analyzing what is in the figure. So we have to analyze the figure. And then for example, years, what are the wages like? What are the wages of the years? So you can see that there are not many changes. And then the age, if you are almost 40, you have almost the same range of salary until you're age 60. And then maybe the 60 to 80, there are limited of people. So you can see all the data here, all the dots are presented as one sample data. Okay, and how do we get the sample data? Is by looking at this. Okay, let's look at another case study. This case study is about sales and advertisement. So the question here is, what are the advertising variables? How do we advertise? I mean, it's not marine, but then we will go through marine as the like. What are the, for example, we want to know the sales level in a company, in UMT. What are the variables that you can think of?
Age.
What kind of advertisement? Facebook, Twitter, IG? How do you want to promote marine science of UMT? If we don't say sales, like we say intake of students. Facebook ads. Okay, very good. What else? What kind of variable? Social media platform. So this is like, how do you want to characterize? If you say social media platform, it goes into Facebook, it goes into Twitter, it goes into everything, right? You categorize TikTok also as a social media platform. So from the old timers to new days, I mean your young generation, your advertisement is on all these social platform. But there are others, for example, news on TV, newspaper. I mean, nobody buy newspaper nowadays lah. And then after that, we have, for example, radio. WhatsApp group. Billboard. Yeah, billboard is a very good advertisement. WhatsApp group. How many WhatsApp group do I know? I only know MMS, your class, and then the first year, second year. That is all the WhatsApp group I have. Okay, so we want to increase the number. Okay, we change lah. We don't do on sales and advertisement. We want to increase the number of students intake into marine science student. So the intake would be year 1, year 2, year 3 means 2014, 15, 16, 17. So every year we will look at the trend. If we put efforts in different kind of social media, right? So the next question is that, for example, this is intake. Okay. For example, you imagine because as we discussed, I've changed the notes on here. So you imagine this is the intake. Okay. And then there are different kinds of tactics that we have tried to produce. One is we go to TV and then promote, and then either we can promote to radio, and then I think newspaper no longer valid in our time era. Change this to social media platform, right? So social media platform, for example, here give you a lot of dots around. Okay, so from this, I'm going to break you up into groups again, and then after that, try to list all the information from this figure. Okay, I need to do a noted by changing this to intake. Okay. Changing this to intake. Okay, all this and then this one to TV, this one to radio, this one to social media. Okay, social media. Okay, I'm going to break you into groups for 10 minutes. List all the information that you can interpret from this figure, and then what is the missing or needed details from the figures from this. Okay. This is a random breakout like last week. I have the same problem of getting my mouse. No, cannot break up without. Okay. No. Okay, I have to stop sharing. And then I will break you all up into number of breakup. Okay, welcome back to the main group. Okay, now you can paste your answer into the chat room again from your group. Okay, let's go and see what are the kinds of data that you have now. Of course, okay, title, legends, title, of course, all figure need a title, but not necessarily for journals. Okay, title are needed when you are going to present it in a PowerPoint. Means you want to catch attention of some people. But in journals, there are no titles. They only have a figure, but the title means figure 1, what is the content? Figure 2, what is the content? It is no longer the title as you can see, like the title that from the top, like big title, sales versus wearables regression. No, we don't do that in science. Okay, parameter for x and y. I think parameter this is should be the number of sales, right? We should be written here like number of sales, and then the radius here is the value. Okay, it can be value, it can be number. Now we doesn't know is it a number or is a value, right? The legend and what time, what is the year and time of the graph. Okay, so we lack of information, but I think one of the group did mention earlier, if this is a figure, what else of other group scale reference? What kind of scale Tan Yichen? If reference should be according to, I'm asking you the figure itself.
The scale is like for the x-axis, the scale is not very accurate as it start with 0, 50, then 100 terus lompat kepada 200. So they are like no very accurate for
Alright.
my idea.
Okay. So here I think it's because 150 and then 250. So according to Excel, the value would come up. Okay, but according to R, the skip is because it should be there lah. It's just that maybe the margin. So you can see that it's a mistake of loopholes over here. Okay, good. I think there would be another problem here because most of the time when we do figure from Excel, this is the one that you see here is figure that made from R software. So from R, you will see zero start not exactly at the X and the Y. If it's Excel, the zero usually start here. Okay, and then it would end somewhere with another legend. But then this one doesn't have zero. So they put you a zero at the different. One more thing that one of the group that discussed that I went to is about regression. Regression. So now you know that this is a simple least square regression. So we draw a line to fit the data. So you can see the sales for TV. The intake, the intake of students according to TV advertisement. You can see as the TV advertisement increase, the intake of students keep on increasing in a very good line. Okay. The question here is that some of you might have noticed already, a lot of the time when we talk about regression, what is the R value? Right? And then the next week you are going to learn what are the difference of small r and big R. Okay, which R is for population and which R is for samples. Okay, and then when we have the R value, another students also answer, is there an equation? Because when you have this R value, usually you have Y sama dengan MX campur C. Betul? That is the common mathematics that you have. Okay, things to be added is the line equation and the R squared equation. Okay, there are 2 points that needed here. One is, where is my mouse? Okay. Okay, one is that we need to know what is the R square value. Okay. This R square value should be higher. This R square might be like 0.5 or maybe 0.7. Okay, according to the equation. This one must be like 0.4. And then it's most probably 0.2 R square. But in statistics, R is not
Very good.
55772. Okay. R value is to tell you what is the changes of the intake with advertisement. But we have to know what is the P value. P value, if you remember, if it's less than 0.01 until less than 0.5. 0.01 means that there is 99% of the data is significant and correlate to the data. So you can see here in this graph, there are a lot of missing components. One, is it significant P value? And then what is the R square value? So you have to understand, actually, you know what are the basic information that needed when we want to create something presentable. So when you want to present something, you must make sure that the information that you want to tell is already in the figure. You don't put a figure like this, and then people will ask you, is significant or not significant? What is the correlation between your two parameters? Why do you want people to ask questions or read from your other materials? Put that all in the figure, so anyone that want to know about that would eventually get all the information just by that one piece of figure that you are putting in. Okay, it doesn't need to be a lot of information that look at appendix 1, look at appendix 2, or look at paragraph number proper, right? So trying to change that. Okay, and then after that, next would be, okay, this is more start to another statistic. Okay, when you come to case study, income versus the year of education. So you look at this graph, look at this figure, what kind of line should we draw? And if you learn your Excel, there are different kinds of lines that you can determine from this. So from here, what kind of lines should you draw? Is it a linear, or is it a polynomial, or is it a, there's only two lah.
Linear.
Mountain say polynomial, Huda say linear, and then linear. There are few linears. So when you want to look at the graph, is that how do you want to interpret, right? So if I'm going to draw a linear line, your linear line, my linear line would be, the linear line would be like this. Yeah. The linear line would be, yeah, you will see a linear line. All right. But looking at that, You have to run the statistical data, and the best answer is tak keluar pula. Okay, cause my mouse and the cursor tak tahu pergi mana. Is polynomial. Okay, you will see that linear is nice, but then polynomial is because the endpoint here and endpoint here, they have a little bit of curve. Okay, so it's a polynomial. So in this study, the case study of incomes and year of education, you cannot have say if you have zero education means you have zero income. This is about the one of the data that I mentioned to you, ratio. Ratio means you need the zero, but years of education, even though it's 0 year of education, they still have income. It's not that if you don't learn, you doesn't have incomes in this case. So in this case, you can see that is a number. So the question here is why there is an equation here. Okay, equation is where we want to start to learn how to do statistics. Baru nak start how to do analysis of data. We are not going to do analysis data this week. I'm going to give all the teaching of analysis data to Dr. Chung that will start next week. So this is an introduction. Y equals to fx plus e means whatever variables from the x or the dependence value like y of x, okay, what are the factors that affect x towards y? Your x is years of education and your y is income. And then e is, this is not e, this is called as the variables of the x itself. Okay, so income is the individuals, and then years of education is one of the variables. So the factors of the variables of this x, years of education, plus other variables, that is the function of f. So we want to connect each of these to the line. I think one of the things that I want to show you is that when we want to create equation, how how actually do we include equation? Like if I want you to type in equation, how do you type the equation? Any equation, y equals to mx campur c. So you use keyboard to key in, right? But I'm showing you one trick. Even from Excel or even from Word, equations should not be written like this. Because for example, if I have this, if I change this to Al-Bayan, kenapa it doesn't change? If I change this to Bradley Hand, you will see it changes. Right? So when you change, but if you see, if I want to change this, I cannot change. It is still the same. It doesn't change to this. It might change the concept. So how you want to add in is that you go to insert. There is one we call equation. Okay. When you want to insert equation, there are a lot of functions where do you want to put. So you put in equation, especially when they have equation of like this. Then you can see here, this I can put in all the symbol. My computer slow a bit. So you can have all the commands in this. You must use this. For example, where is A? Okay, A. So comes up to have A. And then this one, I want to put don't know what. And then after that, I can say equation. I want the equation to have exponential. Okay, so I can have it like, I just insert whatever I want right now, just to get you to know that equation should not be inserted through drawing a line on yourself and then after that putting in according. So if you do all this, you would see that if I put in okay, and then after that, all right. So you can see now, if I have all this change into you will see this change, but you don't see this and this change. So it's a very good trick, especially when you want to write report. Because when you have, for example, 5 students writing a report on an equation or everything, and then after that you put F or X. I mean, students like to Y and X is from the keyboard, but if you take in, for example, this F is from equation. So whatever I change, the F is the same as this F because it's from equation. It doesn't change the format of the font itself. Okay, this is one trick for you to learn on how to do a proper writing of equation, especially on statistic part. Okay, even this you still can put in. You can have dx dy. You can have a lot of function in here, and then you still can type information. Okay, it is not that you cannot use your keyboard. You still can use your keyboard. It's just that this would become one equation. Okay. Okay. So our next question would be, all right. This is a case study, little bit more. A case study of microplastic. I'm taking microplastic because last week we started using plastic as your individuals. Now we know the plastics individuals. From here, from this graph, from this figure, what are the variables that were chosen, that were analyzed?
Yeah.
Okay, year, right? And then what else?
Amount of plastic.
Amount of plastic, so the number of plastic, and if you can see the legend on figure A, what are the other information that they collected? So they collected, yeah, macroplastic, and they also select some natural, but I don't know what are the natural component, but it could be a natural products of plastic or bioplastic. And then the other data is consume macros. So what are quantitative, what are qualitative?
Type of plastik tu kualitatif.
This kind of questions comes in. Huh?
Type of plastik tu kualitatif.
Type of plastic is qualitative. So the macroplastic type and the natural type is all the qualitative, means it categorized into two. And then actually the years, there are two kinds. One is the quantitative years, mean every year they have data. If you look at this, you have 2000, 2001, 2002, every year they have data. And the same data also used as qualitative, where they categorize into a 10 years data. So it's a character, it's a category. So the years are now quantitative and also as qualitative. Okay. The question is, what kind of level does all these 4 level of measurements presented in the figure? If you remember, what are the levels of measurement? Is nominal presented?
No.
What is nominal?
Interval.
Oh.
Interval.
Oh, no, we talk about nominal dulu, nominal. Ada ke tak ada?
No.
Ada.
Tengok baik-baik. Tengok baik-baik, ada ke tak ada? Ada. Amir Akram boleh jawab. Ada tu kat mana? Which one? Which one is the nominal? Ha. Dekat type of plastic. Betul. Correct. Betul. So you have this type of microplastic, the microplastic that is in it category and natural category. So you have the blue and the grey color. That is nominal category. Okay. Ada ordinal ke tak ada? What is ordinal? Ni nak tengok. Tadi saya tengok siapa tengah tengok nota Tengok nota. Cepat tengok nota.
Kepada besar kepada kecil ke kecil kepada besar.
Okay. So ordinal is when you want to categorize best to worst. Ada kod. Amir, tadi dah jawab betul. Ni ada kod. Mana boleh kod-kod?
Ada.
Mana?
Samsung Micro.
Ha? Sam? Ada kat mana? Kod kat tahun. Tak. Tahun is no longer ordinal. Ordinal you have to category them for the largest to smallest. Or you want to categorize them into different component.
Betul
Tak
frekuensi.
ada. Frequency Yeah, so you can see that the frequency here, okay, tadi dah tengok this was used as a nominal. And then after that ordinal, you can see frequency. So the frequency percentage, they already categorized as 1, 2, 3, and 4, and 5. Kan? 1, 2, 3, 4, 4, and 5. So dia dah category 5 is the worst or the worst plastic being frequently in the decade of this one, and then this is the least. So dia ada kategori, okay, using the y-axis here. And then interval, ada tak interval? Ada, ke mana? Which one, which of the data here represent interval? From B. Salah lah. Siapa cakap tadi? 15670. Okay. So sekarang we know the legend, we know the x-axis, y-axis. Y-axis tinggal 2. Tahun dengan accumulative tahun. 1, this is interval. Peningkatan setiap tahun. Okay. So is the A punya x-axis as interval level of measurements because it's a continuous. You can see it's a continuous. But for ratio is what? Ratio is this lah.
Boleh
10 years B. So they compare between the 0 years, mean 1959 as 0 year, until the 10 year. Okay, is a ratio, means they look at the ratio comparison between here to here. And it can be compared between here to here juga. So dua-dua pun boleh, depending on how do you want to interpret the figure. Okay. Now from this figure, you understand the whole concept and the whole characters of statistics. Baru karakter belum nak masuk lagi. Okay. I have 2 more slides. So according to Excel, there are few kinds of figures or graph you can see. So this one I also took it from internet. You can see there are histogram, bar chart, bubble chart. What this kind, all this of chart, and all this kind of chart is so colorful, sangat colorful, and it's so interesting. And all these kind of figure are usually be put into presentation, put into newspaper, news clip where people want to attract the attention. But for science, let's go back into science. This is not the way that it should be presented. It should be presented like this. Data visualization for science, a little bit bored, unless you are looking at taxonomies or you are looking at morphology, where there are a lot of descriptive figures. But for science, it's a lot of the time that they are only black and white. And why it was in that component is that it's all about printing. Okay. Now we have digital. We can take a look at our handphone, what are the colors. But eventually, most of the printings now, they are trying to reduce the printing, and then they wanted the information to be directly observed by black and white or by different label. Every of these, dia ada function dia. For example, if you go to Excel, you can choose your legend, your labels of your data. You nak bubble ke, you nak triangle ke, you nak square. All that have meaning. If you are looking at bubble, means your data is around the bubble. But if you're putting your square, your data have a square component. For example, size of a fish. Okay, the size of a fish, what are the average or maximum minimum? So all these data visualization, we are going to learn through this semester. Starting next week, when Dr. Chung comes back, he will teach you all the statistic, basic information, how to collect data, how to find data, analyze data. When we have finished that, then we will go into what kind of statistic that is, or what kind of test is important for different perspective in marine science, because marine science have biology, geology, physical, and chemistry. So we are going to look into that. And then at the end of the semester, you can present and you can actually debate what are the outcomes of certain kind of tests. Alah, dia dah mengantuk dah tu. Uzai, I rasa dia dah mengantuk, trying to open your eyes already. Alright, so thank you very much for the class. I don't want to be long because it would be sleepy statistic unless we are going to do tutorials and assignment. Thank you very much for today. So this Thursday tak ada class You don't ask me for link this Thursday. We continue next week at 2 o'clock. Okay. Bye.
Okay, Doctor. Thank you, Doctor.
Bye.
Bye, Doctor.
Thank you.
Thank you, Doctor.
Yeah.
Thank you, Doctor.
Bye, Doctor.
Bye.